complex number minus root 3 plus I is denoted by u. So expressed in the exponential form. So just draw the Argand diagram. Minus 3 plus I, that means this is minus 3 and this is plus 1i. So this is the complex number. To find the exponential form, we need to find the hypotenuse or the diagonal line or the modulus. We can just use Pythagoras because this is 1, this is root 3. We can use Pythagoras and we get the modulus, which is 2. And to find the angle theta here, so just find this angle. This is 180 degrees minus theta or pi minus theta. So tangent pi minus theta is equal to the opposite, which is 1, divided by the adjacent, which is root 3. So tangent opposite over adjacent. We use inverse tangent and we get pi over 6. And then we switch basically here. And we get the value of theta. So this is the exponential form of u. Hence, show that real and state its value. So u to the 6th power. So if we use to the power of 6 to the power of 6, this 2 is to the power of 6, which is 64. And this e to the power of something, again to the power of 6, we multiply the powers. 5 over 6 times 6, that's just 5. And because this is in bigger than 2 pi, just use the principal axis. So we subtract multiples of 2 pi here. So we subtract by 4 pi, we get just pi. Okay, so this is the exponential form in the simplest form. But we need to state its value. So the best way is to just draw the Argand diagram. We know the modulus is 64. We know the angle is pi. So this is the complex number. So it's gonna be minus 64, 0 basically. So minus 64 plus 0 I, or simply minus 64. That's pretty obvious, but you can also use the fact that e to the power of pi I is the same as cis pi. Cis means cos plus I sine. So cos pi plus I sine pi. Cos pi, use a calculator, is minus 1. Sine pi is 0. So this is just 0. So again, we get minus 64. Okay, this is u to the 6th power. Now remember, previously we know this is u. And to sketch this locus, this is arc something, so it's a half line. To find the starting point, we need to make it z minus something. So it is z minus u. So this is u. So this is the starting point. The angle is from 0 to pi over 4. So this is the angle we're going to use from positive real axis or from positive x-axis to 45 degrees or pi over 4 counterclockwise. So we don't need to sketch this, but in case you want to visualize it, this is the starting point, minus 3, 1, and the angle is from positive x-axis, so the horizontal to the right. This is what we need to shade for the half line. For real value of z means basically x. So x is smaller than 2, so we have a vertical line, we shade the left hand side, and we combine the blue and the green, we have this kind of triangle. We need to shade the triangle, label the starting point, label the x-intercept and the y-intercepts. Okay, now find the greatest value of the modulus of z. So z is the complex number or the line from the origin to any point in the region. Okay, so from origin to any point in the shaded region. So these are all possible z. But since we are looking for the greatest value of the modulus, we need to find the longest modulus. So it's gonna be from origin to this vertex here, to this point. So this is what we need to find, this length. So We know that this is root 3, this is the origin, this is minus root 3, so the length is root 3, and this is origin, this is 2, so this length is 2. And since this angle is 45 degrees pi over 4, it's isosceles right angle triangle, so whatever this length is the same with this length. So this length is root 3 plus 2, this length must be also root 3 plus 2. And of course this is 1 because this is I, so this length is 1. So now we have this total vertical line, which is 3 plus root 3, and this horizontal leg, which is 2. So to find the diagonal or the hypotenuse, we use Pythagoras. 3 plus root 3 all squared plus 2 squared, use a calculator in 3SF. Alright, I'll see you again.